Welcome back, and now we're going to follow on from last week's video, which was about constructing your EDTracker device. So now we've got it built. We've got one here and it's completely raw. There's no code flashed into it. You can tell by the fact there's no flashing LEDs on it. What we're going to go through is programming it, so putting the code into it, and we're going to start from a completely clean slate. One thing to clarify, when people are watching this, you might think, why is this guy using Windows XP? It's in a virtual machine, so it's a completely stock install of Windows XP. The reason I've done that is so that we can see the whole driver install process and so on and so forth. So yeah, XP, just because that's what I use in VMs, they're lightweight, but it'll still work obviously with Windows 7, with Vista, with Windows 8, no problem. But you know, the screens will look all slightly different, but it should still give you an idea of what to do. Okay, let's get started then. First thing to do then is head to the edtracker.org.uk website. Basically here we've got some instructions on building, that's constructing the device, using it. We've got the software, the flashing process, all detailed in writing on there. So if you don't prefer a video, you prefer written, all the instructions are there. And there will be a frequently asked questions and stuff like that. What we do want to do is go to the downloads site. What we're going to, let's go over downloading all the stuff first, and then we'll install it in a second. So go to downloads, and if you go into the software category and grab the EDTracker 1 IDE device.zip. So download that. Then you also want the Arduino software. Now what we're going to do is we're going to do this talk over the early version of the EDTracker code, EDTracker 1, let's call it. There is a newer version, EDTracker 2, with a fancy kind of graphical user interface that eases the calibration process later on. But for both versions, this initial stuff can be useful. So go to the Arduino website, go to download, and download one of the IDEs. Now you've got a stable one, 105, or a beta one, 156. You can use either. The instructions that we're going to put here are for the beta one. The main reason for that is the beta one has got signed drivers in it, which are going to be better for Windows 8 users, and it's got slightly more features in terms of the code it compiles on here. It's got more up-to-date libraries, wider Arduino support for other Arduino devices. Not that that makes a difference for this. It does compile slightly larger code, but it's also got some nice features about where it pulls your files from. So these instructions are going to be for 156. If you do go with a stable release, some of the folder names will be slightly different, but if you've got an ounce of intelligence in you, I'm sure you can figure out where they go. So we're going to download that as well. While that's downloading, we're going to head off to, again, link from the EDTracker website. There's a source code tab. From there you can go to EDTracker 1, which is what we'll do here. We'll do EDTracker 2 again in maybe the next video. Let's just work on the basics for now. EDTracker 1, and that will take you to the GitHub repository for the source code for the project. We only need a few of these, but it's easier to just do the download zip button, click that, download the whole lot. You'll also see in the text here that it requires an I2C devlib, another library contributed by a chap called Jeff Roberg. The link is there, click that, and then you'll see popular repositories I2C devlib. Click that one and grab that as well. Again, rather than grabbing individual files, just click the download zip button, grab the lot. We'll deal with that later. Okay, so we've got our Arduino IDE, our drivers, our IDE device. We are good to go. Okay, so first job is to install the Arduino IDE. So what I'm going to do is I'm going to open up the Arduino zip. If you downloaded the installation exe, just double click it and follow the instructions. Me, I'm going to unpack that into my program files. Okay, we're back. Right, so we've got that extracted. We're in the C column, program files, Arduino 156R2. There we go. Now what you want to do is just run up the Arduino once, because it's going to create a load of folders in my documents that we need. So just run it up and then close it. Sounds a bit odd, but now if we go to my documents, we've got an Arduino folder. So now we're going to go and unpack some of the folders that we've downloaded, the libraries. So there was the I2C devlibs from Jeff Rayberg. So if we open up that zip file, you'll see a folder of the same name inside. Now the MSP430 folder we're not interested in. So open up the Arduino one, and all of the folders that you see in there, grab the lot and extract them into your libraries folder that is now under Arduino. Overwrite all of those. Okay. We also took an EDTracker 1 IDE device zip, if you remember, from the EDTracker website. Open up that and you'll see a hardware folder in it. Now on your local PC, go to wherever you installed your Arduino IDE, so probably program files Arduino 156R2, and you'll see a hardware folder in there as well. So if you open those up, you'll see we've provided an EDTracker 1 folder, there's an Arduino and a tools one in there. Drag the EDTracker 1 folder over into the hardware folder underneath your Arduino install. Okay. Last but by no means least, we need the actual source code for the EDTracker project. These are called sketches in Arduino speak, so they go in your My Documents Arduino folder. So open up the MPU 6050 Arduino Micro EDTracker Master Zip that you downloaded off PocketMoon's GitHub, and in there you'll see an Arduino sketch folder, and inside that an MPU 6050 Joy folder. Drag that one, extract that into your My Documents Arduino folder, and that's your, if you look inside, there should be an INO file, which is an Arduino sketch. So that's good. So that's the main code for the EDTracker. So take the MPU 6050 folder that's in your EDTracker master that you downloaded from GitHub, just underneath Arduino sketch, look, an MPU 6050 folder, and in your libraries folder you'll see on your PC, you'll see there's an identically named folder as well. Drag the one over the other, merge the folders, replace any files. If it overwrites them, that's fine, let it overwrite them. That just updates the files to some alternative versions with better settings in them. Right, so we're ready now to install the drivers for the device. Now what I'm going to do, because basically plug your device in, because I'm cheating and using a virtual machine, I'm just going to attach it to the VM. And what you'll see is, blah blah, it finds an Arduino Leonardo. Don't worry about that, that's fine. It's basically compatible with an Arduino Leonardo, the micro. It'll look for drivers and it won't find any. So we're going to point it to them. No point searching on Windows Update, you're not going to find them there. Install from a specific location. And browse to where you installed your Arduino IDE, so program files, Arduino, blah blah blah. You see there's a drivers folder. Click that, click OK, and let it search away, and it will find the drivers and install them. There you go, Bob's your uncle. Now we can launch the IDE. So run that up. It's saying the hardware is ready to use. So we're ready to put a program into it, basically. In your IDE environment, we need to choose our custom device for the EDTracker. So if you go to Tools, Board, choose EDTracker 1. Go to Tools as well. We need to set the port. Basically, this pretends to be there's a COM port that is used to program this. So go to Port, and you'll see some detected COM ports depending on your PC. Generally, one of them will look fairly new. It's probably the last one. Choose that, and that basically tells the PC that we're programming the Arduino over that COM port. If it doesn't work and you've got loads of COM ports, just try them until you find the correct one in the next steps. And we are ready to go. So we're going to go to File, Sketchbook, and we'll see our MPU 6050 Joy sketch. Click that and load our sketch up. And here you can see the code for the EDTracker device. Now if you scroll down to this line here, line 43, you'll see there's a line that's got the word debug output in it. And it's commented out. Commenting is 2 slashes at the front. And that means that the program won't execute this line. Now for the early stages, we're going to turn this debug output on by taking the comment out. So delete those 2 slashes so that the line says #define debug output. And this way we'll get some output over this COM port into the PC so we can check what's happening, check that it's working. So when we're all ready, we've got our EDTracker 1 on COM3 down here in the corner, so it knows it's connected to the Arduino device. We're going to compile it and upload it, and you can do that by clicking this upload button. So first it will compile the program, compiling sketch, you'll see down here in the log. And then it will upload it to the device. And now you see the device has been redetected as on a different COM port basically. So we're going to just tell it, yep, that's fine. Probably automatically will work. Let's try that. Yeah, because now it knows where your drivers folder is. And now you see it's recognised the bootloader. Don't worry about the technicalities of what this is. The bootloader allows us to program the device in all the time. So okay, it's saying it's all ready to go. So what we're just going to do is we're going to click upload once more, and now it's recognised that device. What I'm going to do is keep an eye on these indicator LEDs. You can see it's now saying it's uploading. You'll see some LEDs coming on now. And it's done uploading. This is the magic bit. So this is where if you open up your tools, port, check that's okay, open up your serial monitor, and you'll see some numbers being spat out. What is going on? Well, that's a good thing. This is good. This means the device is working. What you're seeing here are the axes that the device is detecting. And while it's not very obvious what the numbers are, they're basically your X, Y and Z axis. So if I reset this, if I twist it on the X, you'll see the first number change quite considerably. I'll twist it the other way to the positive. So these first 3 columns, first 3 numbers are your X, Y, Z axes, and your last 3 columns are calculated drift on them basically, which we will come to. So this is good. This basically means your device is working and is ready. What we do want to do though is we want to calibrate it. At the moment this will be quite off in terms of settings. To calibrate it, what we want to do is we want to keep it still. So I'm going to put it in my clamp, but you know, sticky tape or blue tack it to a book or something heavy and just put it flat on the desk, and don't touch it and don't move it. And then what we're going to do is we're going to unplug it. What we need to do is just reset the power on it. So I'm going to take that off. In fact, we can close the IDE. Well, no, we'll keep the IDE going because we'll want the port. So I'm unplugging it. Then I am plugging it back in. And when you get the light, press the button. in the first 10 seconds of it being plugged in. And you'll see if we go back to our serial monitor, it's saying state 1 there. What's state 1? Well, it's going through an internal calibration step. So again, just to clarify exactly what we did there, we unplugged it, we plugged it back in, and then within the first 10 seconds of plugging it back in, just tap the button, then hold it still, don't touch it. And then if you want to connect your serial monitor up in your Arduino IDE, again, that's Tools, Serial Monitor. You'll see you won't see numbers being spat out until this point here, look. And it'll say save offsets, it'll spit some post gyro numbers out, and then it will carry on doing what we saw before, spitting out the numbers. And now you'll see it's calibrated, so it's calculated some offsets that are needed for the sensor while it's being held still, and it's now going to be a lot more accurate in game. It's very, very critical, I can't stress this enough, that while you're doing that calibrate step, that click the button in the first 10 seconds, you do not move the device, because it will just throw all the numbers out. You can redo it at any time you want, unplug it, plug it back in, button in the first 10 seconds, and redo that step if you want to, no problem. Now what you want to do is you want to leave this going, and if you can leave it for as long as possible, the better. I would suggest anything less than 10 minutes pointless, 30 minutes to 60 minutes perfect, over 60 minutes leave it overnight, an extravagance but will certainly get you an accurate number. What we're looking at here now is this third from last number here. You can see at the moment it's 0.74, 0.76, and this is how much the x-axis is changing over time, and it's a rolling average, so the more samples we get, the more accurate it will get. But it's currently calculating how much the x-axis is changing even though it's not being moved. So again, it's critical that we don't move the device, and we watch this number and we give it 20 minutes to average out and figure out what it's set to. And this number will become your drift number. Now what I'm going to do for the sake of this demo is I'm not going to sit and wait 20 minutes. You can see the number at the moment is minus 0.63, so let's say minus 0.6. So what we're going to do is we're going to stop that, minus 0.7 now. And in our code, you'll see very much nearer the top there's a float x drift comp equals 0.00, and we're going to put that number that we just read into there, so minus 0.70. okay, we can do drift compensation on the y and z axis, but you don't really get drift on those axes. It's only the x axis, so we're going to save that and push it back up to the device. So we're recompiling the code with this drift compensation included. We're going to push that up, just click the upload button, it will compile, and what we're doing now is we've adjusted the program so that every second it actually moves the x-axis inside. It kind of figures the x-axis has crept to the left by 0.7 of a point, so I'll manually tweak it back to the right by minus 0.7. So basically, as the sensor inside starts to wander off thinking it's going this way, the program compensates for that by saying, well, I'll drift this way the same amount, and that will get rid of your static drift. So if we go back to serial monitor, once it's done uploading, we can see some numbers now, and if you basically leave that going, you should find that those average values tailor towards 0. A certain amount of drift is acceptable, but at any point, remember, you can, not in that first 10-second period, but when you're playing with the device on your head, you can re-zero the axis. So you can see at the moment they're saying 82, 30 and 16, 14 whatever. If you just tap the button briefly in game, it'll do recalibrate and it'll re-zero them. So you can see the x-axis now is measuring 11, and it will fluctuate initially and then it'll stabilise. The thing to point out is these numbers, you know, they're to the order of 32,000, yeah. So you can see as I turn this device, you can see as that's adjusting up to 16383. So you've got a resolution of 32,000 points from left to right. It moving by a factor of 10 points, you're not even going to notice that in game. It's very, very minimal. So, you know, some variance in these numbers is perfectly fine. We're talking an incredibly fine piece of detail. And there we go. So we've done a short calibration there, but basically your device is now ready, and you should be able to attach that to some headphones or however you want to manage it on your head, and take it for a spin in game. Okay, quite lengthy, quite detailed, but there's all the steps to programming the EDTracker 1 version of the code. What we'll do is, in a separate video, is I will go on to the EDTracker 2 with the new user interface, which just eases some of that calibration process. It gives you a graphical interface on your PC to do it, so that might be a bit easier for some people. Okay, that's enough for today for this one, and we'll carry on in the next with the second version. I'll see you later.